Hi, this is Venkadeshan, Assistant Professor, Department of Chemistry, St. Joseph College of Arts and Science College, Kannalur. Here I am uploading some important topics on chemistry that is very much useful for the competitive exams like CSIR, GATE, NEET and JEE Main and advanced examinations. Thank you. எல்லாம் ஆதிபகவன் முதற்றியுள்ளது என்ற திருக்குறளின் தொடக்கத்தோடு இந்த பதிவும் ஆரம்பிக்கிறோம். Types of crystal systems. One is cubic, second one is tetragonal, third one is rhombic or it is orthorhombic, fourth one is monoclinic, fifth one is triclinic, sixth one is trigonal, the last one is hexagonal. So these are all 7 types of crystal system. So each crystal system we are having as different different edge lengths and also different bond angles. They are all comes under some specific unit cells. For cubic system, all the edge lengths are equal and all the bond angles are equal to 90. The unit cells are SCC, BCC and FCCs. For tetragonals, A equal to B, but B is not equal to C. And all the bond angles are equal to 90. Unit cells are SCC and BCC. The third one is rhombic. All the edge lengths are different, but all the bond angles are same. The unit cells are SCC, BCC, FCC and ECC. The fourth one is monoclinic system. All the edge lengths are different. Alpha and gamma that is equal to 90 degree, but beta is not equal to 90. The unit cells are SCC and ECC. Fifth one is triclinic system. All the edge lengths are different. All the bond angle is not equal to 90. They are considered SCC unit cells only. The sixth one is trigonal. All the edge lengths are equals. Bond angles alpha and beta only we are calling as equal to 90. Gamma is not equal to 90. They are considered SCC unit cells. The last one is hexagonal. Edge length A and B are equal, but B is not equal to C. The bond angles alpha and beta is equal to 90, but gamma is 120 degree. It is considered SCC unit cells. So these are 7 types of crystal system. From these, I am marked as cubic and triclinics. Cubic systems see that bond angles and bond edge length all are equals. But for triclinic system, edge length are different, bond angles are also different. So cubic system is a symmetrical system. Triclinic system is an unsymmetrical system. Okay. Once again I repeat, cubic is a symmetrical one because edge length and bond angles are equal. Triclinic system, edge length, all the edge length are different, all the bond angles are different. So that is why it is unsymmetrical one. There are 23 symmetry elements are in cubic systems. And next one is how many number of atoms in SCC, BCC and FCCs. So for number of atoms in SCC is 1 because each corner atom it is shared by 8 unit cell. That is why you are getting as only 1 atom. Then for FCC, apart from the corners you are having as 6 atoms the faces. Each face is shared by another unit cell. That is why you have to take only the half. So total is 4 only. Next is number of atoms in BCC. Apart from this corners you are having center. So total is 2 atoms. So number of atoms SCC 1, FCC is 4, BCC is 2. Then in a cube, 8 corners are there, 6 faces and 12 edge centers and 1 body centers. Each cube having this types 8 corners, 6 faces, 12 edge centers and 1 body centers. Next one is packing efficiency. Packing of constituent particles. So when we are taken as in very dotted form, lattice point that we have so many points. By avoiding the voids, we are going for cubic close packing arrangement. By the cubic close packing arrangement, we are getting as 2 types. One is square close packing, other one is hexagonal close packing arrangement. For the hexagonal close packing arrangement, we are having as AB pattern type arrangement. For the cubic close packing arrangement, you are having as ABC pattern like arrangements. Packing fractions. So that is the packing efficiency. So this is for SCC. For SCC, if you are having the length derivation, you are getting as 5 by 6. Pi by 6 is equal to 0.524. If you are taking the percentage, then it is 52.4%. Second one is FCC. FCC having pi root 2 by 6, that is equal to 0.74. Percentage is 74%. For third one is DCC, body center cubic, pi root 3 by 8, that percentage is 68%. These three are packing efficiency of SCC, DCC and FCC. Next one is, it is exceptional one, diamond packing efficiencies, that is equal to pi root 3 by 16, that they have the percentage of 34%. Then whenever you are having the arrangement of an atom, there will be some space is there. That is, we are calling it as voids. Here we are having two types of voids. One is octahedral voids, another one is tetrahedral voids. So here you can see that there are 4 atoms. That is, from the 4 atoms we are having one small hole is there. That is, we are calling it as voids. That we are having as octahedral voids. Sorry, tetrahedral voids. For octahedral voids, we are having 6 atoms having the hole. Then it is called as octahedral voids. Octahedral voids are n number of voids. Example, sodium chloride if you are taking means that is comes under octahedral voids. Tetrahedral means it is in twice of octahedral voids. If you are knowing the octahedral voids, then you can easily calculate the tetrahedral voids because it is in twice in the numbers. Next one is radius of voids. That gap is that hole also having the radius. If you are having tetrahedral voids, then the radius is equal to 0.225 r. If it is voids in octahedral, then the radius of voids is 0.414 into r.